All right. Understanding the zoom function. You know what? I will skip that because you know how to use zoom. Okay. Remember, right? You have zoom standard, zoom fit, zoom stat if you do regression. We talked about them. Sometimes I do this first, this unit first, so that's why I have that in there. So anything about windows and whatnot, we're going to skip. We're going to just focus on this part here, graphing using technology. Okay, and I will say this, a little subheading here, systems. Systems of equations. And that just means more than one. Okay, so a system, I don't know if you remember from grade 10, you probably solved systems of equations. Do you remember that vaguely? Solving by substitution, by elimination, and by, what's the other one? Substitution, elimination. Forgot the other one, sorry. But anyways, we won't need to worry about that because we've got a graphing calculator that helps us. So it's a lot easier, okay? So in this case, I want you to rewrite these equations, graph them on the calculator, find the intercepts. We're not going to use technology. You can cross that out. We'll do it by hand. Determine the y value when x is equal to 7, the x value when y is equal to 15. That one is not my first concern right now. We're going to focus on these three items right there. And continuing where we left off yesterday, these are both cleaned up. Would you agree with me? Sorry, is this one cleaned up? Is this one cleaned up? No, it's not cleaned up. Okay, so sometimes you have to clean up first. So I like to find the intercepts right away when it's cleaned up. Okay, so this one is cleaned up. It's not a technical term. You'll never find that on a textbook, right? But it's already cleaned up, check. So I just do this, x-intercept, y-intercept. And I omit the step where I show that y is equal to 0 in this case, for example. Y is equal to 0, this whole thing disappears, so you're really just left with negative 6x is equal to 30. Okay? And then you divide both sides by negative 6. So x is equal to 5, negative 5, right? And so negative 5, 0 is that one point where it's going to cross the x-axis. The same thing for the y-intercept. When you're figuring out the y-intercept, x is turning into 0, okay? So this whole negative 6x is 0, it's gone. So you're just left with 2y is equal to 30. You divide both sides by 2. Y is equal to 15. And in this case, they're both round numbers, which is not always going to be the case. You're going to have decimals in many cases, and that is fine. Okay. So these are the intercepts. Let's rewrite. And rewrite, what I mean by that is I want it in this format. And the reason, I'm telling you already, the reason that I'm going to ask you to rewrite is there's two reasons for it. So we can graph it on our calculator, and later on when we're supposed to shade, it's going to be a lot easier to determine if you rewrite it. Okay? So let's rewrite that. So basically, I will start with it again, just so you see in your notes what I mean by that. So basically the 6x, the negative 6x comes over, so you end up with 2y is equal to positive 6x plus 30. And then you divide both sides by 2. Y is equal to 3x. You want to see the common error, so that way you won't forget. It's like, oh yeah, I divided 6x by 2, good, 30. Now the 2 affects both of them, right? So 30 divided by 2 is 15, so this should be 15. So there you go. Hopefully you remember now. So that's the rewritten format. That's something I can graph on my calculator. We do the same thing on the other side. We're going to graph on the calculator shortly. I have the benefit of you knowing how to graph with a calculator at this point. So I'm going to use that to my advantage here. So clean up first. Okay, so basically what I will do is I'll take the negative 100, bring it over to this side, and I'll take the x and bring it over to this side. I want all the x's and y's on one side, and I want all the numbers, the constants on the other side. So it's, I'm going to do this in this order: negative 4x minus x minus 5y, 5y is still there, is equal to 100. We combine these two to negative 5x, negative 5y is equal to 100. And now I can find the x and the y-intercept. So, to find the x-intercept, y turns into 0, so I end up with negative 5x is equal to 100. Divide both sides by negative 5. X is equal to negative 20. Negative 20, 0 is the x-intercept for this line. And the y-intercept is going to be the same numerical value. So x turns into 0, so you end up with negative 5y is equal to 100. There's going to be a lot of this stuff, so I need you to be comfortable with it and not get your signs wrong. Okay, getting the sign wrong is a big problem. Why do I find the x-intercepts? Because graphing is going to make it a lot easier if you have those. And now rewrite. So basically, I'm going to take the negative 5x minus 5y is equal to 100. And how about we write y is equal to mx plus b? That's what I'm after. So it's negative 5y. The negative 5x comes over adding and we divide both sides by negative 5. 5 divided by negative 5 is negative 1, so it's negative x really. 100 divided by negative 5 is negative 20. This should not surprise you, right? Like, if you think about it, you had the 15 as your y-intercept, and when you rewrite it, you end up with a 15 there, right? You have a negative 20 for your y-intercept here. You get up a negative 20 there. It shouldn't surprise you. That's actually what you should see. If you don't, you should check your work. Okay. So I would call this equation 1, right? And this is equation 2, so to speak. Let's type this into our calculator, and basically point number 4 is asking us, when x is equal to 7, what is y, right? That is what it's asking us for there. And point number 5, let me just bring that up a little bit. Point number 5 is asking, what is the x value when y is equal to 15? Okay. So do you remember how to do this using your calculator? When you know the x value, what are you going to use? Second, trace value. Do you remember that? Value. X is equal to 7. That's how you're going to find that one. And when you get the y value, we go to y equals, and we let y2 equal to that y value we're given. And then we're going to go find the intersection, second trace intersect. So let's go ahead and do that right now. So the step is, look at that, isn't that beautiful? Next year, in grade 12. Okay. 3x plus 15, and we hit graph. My graph isn't the greatest, so I'm going to do a zoom standard, zoom 6. It's pretty good. I just don't see the y, so I'm going to go, am I going too fast here? Window, and I need to increase the y max. I keep forgetting that it's been a little while, right, since you did this stuff. I'll turn y max into 20, and that's a pretty good graph there, right? You see the x and the y intercept. So basically try to do a zoom standard, zoom 6, and then increase your y max by a little bit until you start seeing it. So let's do this first one. Second trace value, x is equal to 7 and y is equal to 36. Okay, so y is equal to 36. By the way, if you just plugged in 7 for x here and you just solve the equation, you would get the same answer. So it's up to you what you want to do. You want to insert 7 into that and do the arithmetic, or use your calculator. Completely up to you. For this one, we let y2 equal to 15. We hit graph, second trace 5, enter, enter, enter. And the intersection is 0, 15, so x is equal to 0 there, because it is our y-intercept, right? So we have that. I'm going to ask you to do the same thing for that second example here with this equation. So I want you to enter the equation and basically find out when x is equal to 7, what is the y value? What is the x value when y is equal to 15? You don't have to show me keystrokes on this one. Just come up with the value, okay? What is the value in each? What's the missing value in each? Just to recap how to use your calculator, how to adjust your window, and all of that, okay? So I'll give you a minute or two to... If you did this right, y is equal to negative 27, and x is equal to negative 35. You would have had to change your window significantly to make this work. X min would probably be, what, negative 50, negative 60. And notice, right, this line is going down, right? And it's meeting the y-intercept at negative 20. So just letting you know that that's probably what you have to do. And if you have issues with it, I'll help you soon. Skipping. All right. Let's go to page 11. And again, a lot of this is review. So maybe I'll just mention it, but if you're trying to find the point of intersection, that is a word. I'm going to use this quite frequently, points of intersection. Soon I will refer to them as POI. This is on page 11. So if you want to find where they intersect, these are the steps we take. enter each line into Y1, Y2, Y3, and so forth. Press second trace intersect, select the first line, select the second line, press enter, and then you should start to see the X and the Y values of that point of intersections. You may have to adjust the window. That is always fine print, right? Everything I do, you have to adjust the window to make that happen. So determine the point of intersection for the lines created by the equation above. So let's go ahead and do that. We're going to enter both of the equations we just found. I already have the first one in there, so I'm just going to go negative x minus 20. I'm going to put the second one in y2. And let's hit graph. And I don't see the point of intersection. Okay, so what do? You have a lot of tools available to you. Maybe you just know what you need to do in terms of changing values. I'm going to use zoom. I'm going to give zoom fit a try. Not bad. Actually, that's all you would need to see the intersection, and you're good to go. When there's only two lines, guys, it's really just second trace, intersect, and then just press enter 3 times. You don't have to select any lines, you just enter 3 times, and there it is. It's negative 8.75, negative 11.25. Okay, so I'll just say this. Y1 is 3x plus 15. Y2 is negative x minus 20. Then I went second trace, intersect. That's part of your work. You know what? I'll be fine with you just doing this if it's within the question. You don't have to actually write in what you're doing with Y1 and Y2. And it is negative 8.75. I lost my answer, so negative 11.25. Very important for us. We're going to actually key in on that. I want to find all the points where those lines meet. Okay? And most importantly, I want you to be able to graph multiple lines on the same plane. The nice thing is 99% of the time I give you a nice grid with boxes. So let's do this. I will do this. You've got, just for note-taking purposes, you've got this one and you've got this one. Okay. The intercepts for the first one were as follows. Okay. I'm just copying and pasting. So you've got your x-intercept and your y-intercept for that one. Then you look at this line, and it's negative 20, 0, 0, negative 20. The reason being is I'm going to ask you to find the intercepts, rewrite the equation, and find the intercept. So this is normally what you will have anyways already available. You will have done the work for that to show up. So now you want to copy them onto this. So think about it. For this line, you need to go down to negative 20 and negative 20 this way, right, for this to work. So that's something that you must encounter. In terms of this intercept, you go all the way to 15, and you go to negative 5. So what I'm going to do is I'm going to go 20 in each direction, and that will do it for me. Okay, so I will go like this: 5, 10, 15, 20. There you go. Try to keep the distance the same. Negative 5. Sorry, I'm just going to go negative 10 to have less. Okay, so keep them about the same distance. I use the same scale for my x-axis. In this case, that will work. You might have to do hundreds, you might have to do thousands. You'll find out soon enough, right? So let's graph this first line here, -5, 0. And remember, these could be decimals. In fact, they will be decimals quite often. Just put it close enough. 0, 15 is right here. And then you graph it. I would graph that line right away so you know that those two represent that line right there. Don't be shy, extend your lines. Keep extending them, not a problem at all. You don't have a word problem at hand here. Then you've got -20, 0, and 0, -20 right here. That's this line. And let's label them. -20, sorry, not +20. And my hope is that when you label, that you will be able to catch your mistake if you made a mistake. So for example, let's say you're labeling this line and you end up with a negative slope, right? You actually, yeah, nice graph, and I'm labeling -3x, wait a minute, negative, it should not be going up, right? So I hope you catch yourselves like, wait a minute, I need to fix something. Something went wrong here. Another thing I want you to look at is the intercept. This is going through 15, which you see. It goes through +15. So this is kind of like to verify that what you're doing is correct. I labeled this one here, negative slope from left to right. This is going down, and it's going through -20. Boom. So you know you're doing... We're fairly certain this looks all right. And then last but not least is you look at your graph on the calculator and you might think, Mr. Dirksen, this one doesn't look at all like what you have here. Would you agree? It looks a little off. It's because the calculator is using a different scale. Can you see the little ticks here and then a wider spacing here, right? So that's normal. So it's not always an indicator that you're doing something wrong. What I would focus on is one is going up, one is going down, right? One is going up, one is going down, so that works for us, okay? In fact, how about this? We get it already. You don't have to, I'm just making sure, right? Let's say I use the same min and max that I have on my window right now, and I regraph it. That looks a lot more like what I have here, right? Because now I'm using the exact same scale. So just keeping that in mind. And last but not least, the POIs. In this case, there's only one intersection between the two lines, right? So that one is important. That one is -8.75, -11.25. I'm gonna try an exercise here with you guys. We're gonna just imagine that we're gonna create another line. I'm just gonna give you a line. We're gonna enter it into our calculator, and we're gonna see what happens with our points of intersections. Let me just try this. I'm gonna make one that has a fraction as a slope. So let's say it's 3/2 x plus 10, let's say. Yeah. Let's try that. Can you type this equation into y3 real quick? So let's say I was mean, right? And I say, hey, there's actually 3 equations. How would you deal with that? Good luck, right? So I always use brackets when it's a fraction. So I put that fraction and I go 3 divided by 2. That's how you type in the fraction, x plus 10. Got it? Hit graph. Maybe to all be on the same page, let's all have our windows at -2020, -2020, then we're all looking at the exact same screen. Hit graph. So technically now, don't graph this on the paper, but we have what it looks like. It's going to go through 10. You've got something going on like this, right? So now you have 1, 2, 3 points of intersections. Okay? I've created more intersections between the lines that are there. That's when it gets a little trickier. So how would I find that point of intersection there between the red and the black line? How would I do that? Follow me, please. Second trace, intersect, and now you can't just press enter 3 times just like that because you've got 3 lines going on, okay? So we want to find, if I want this one, we want to be on the black line and the red line, correct? What color is everything in right now? Everything is blue, so I don't want that one. So I'm going to jump, go up and down arrows. Jump until you get to either the red or the black. See, now I'm on the black line, right? If I keep going up with the arrow, I'm going to go to the red one and then cycle through blue, black, red, right? I'm going to go until I stop on the black line. I hit enter. I'm selecting the black line. And I want the next one to be the red one. So you keep going up and down arrows until you get to the red line. See, everything is red when I get on the red line. Hit enter again. And when it says guess, hit enter one more time. And it will jump to that intersection that you're interested in. Right? Let's try to find this one. What's this one? Between the black and the blue, right? So we go second trace, intersect. Sorry, second trace, intersect. We want to be on the blue line, so hit enter. We don't want the red one, so I keep cycling until I get to the black line. Hit enter. Enter one more time. It's going to jump to that intersection right there. Okay? So that's how it changes when you have multiple lines. Let's say you're like, no, Mr. Erickson, this is too painful. I can't do this. If you want this intersection, you only want black and blue, right? Black and blue. So you go to y equals. You go to the red one. Go to the equal sign and just hit enter there. If you were to graph now, you're only going to see the 2 lines that you want. Got it? One more time. If you don't want a certain line, go to it, go to the equal sign, hover over it, hit enter. So you deselect it. Then you hit graph again. It's only going to graph the 2 you're interested in. And then it's just second trace 5, enter, enter, enter. You don't have to worry about selecting the 2 lines you're interested in because those are the only 2 that are there. Does that make sense? What if I want the black and the red? I'm glad you asked. I didn't ask, but anyways. Right? Then there's those 2. And then it's just second trace 5, enter, enter, enter. Right? So whatever floats your boat, whatever is easier for you, use that, okay? So I wanted to just do it right here so I don't have to like redo another example with 3 lines. So what I'm going to ask you to do is take some time practicing this. And I have it in a format on page 12. I'm going to say for what we're doing right now, I want you to omit this. Don't cross this out necessarily, but this, how about I call this optional? So filling in these 2 columns right now, honestly, I don't want you to spend too much time on that. Because we've done graphing, we've done quadratics, you know how to do that. What I want you to do instead is this. So I'm gonna cover this up, right? So this is not really what I want you to focus on. I want you to take every single equation, rewrite it, right? So rearrange it I want it in this format. Okay. You rewrite this in the correct format so that we can actually enter it into a calculator. I want you to figure out the x and the y intercepts, just like I've shown you how to do, right? You go, to be honest, to find the intercepts, I would go back to the original here, right? And do that for all 4 of them. So there's 4 of them, okay? And then I want you to type them all into your calculator, all 4 rearranged versions of this. And I want you to find the points of intersections between all of these lines. So first I'm asking you for the intersection between y1 and y2. So if you only want to turn those 2 on, then that's what you do. Find the point of intersection. Then between y1 and y3, so between these 2 lines, y1 and y4, and so forth, okay? This is good practice. This is what you're going to need to know how to do later on. So I'm going to give you some class time to do that. And we'll see what happens, okay? Decimals are fine. Fractions are fine. Can I just say something about this one here? This one usually gives people a bit of a headache. When you have fractions like this, what I tend to do is I multiply both sides by whatever that denominator is. So maybe I'll just give it away already. Like you take the whole equation and you go times 3. So basically this third and that third will cancel out, like they'll be gone. And then on the right side you have to go 4 times 3 to get 12, right? And then it's much easier to work with and rearrange. So that's for you there. So I'll leave you to it for now. I'll post a key so you can check. And I'll walk around and make sure you're on task, okay? Maybe I know some of you are going to be done sooner. The goal is to, watch this, dun, dun, dun. I want you to graph all 4 of those lines on this grid. But the bonus is I already have given you a scale, and I promise you that it fits on this grid. So you don't have to like guess what my scale is and whatnot. So it should be doable if you did it right. Maybe check the answer key to see that your equations are right before you graph. That'd probably be a good move. So you don't have to redo everything.